All right, guys, today we're talking about solving quadratic equations. So if you weren't here for class, go ahead and print off the notes and follow along. I'm going to go kind of quick today. If you need extra help, if there's something you didn't understand, come in and see me. But we're going to try and shorten this video up a little bit for you. Quadratic equations is really similar to what we talked about yesterday. A quadratic equation is an equation in the form of ax squared plus bx plus c equals 0. So it's just like a quadratic function, except for instead of equaling y, it equals a specific number. It equals 0. And this is what we call the standard form of the quadratic equation. And there's a lot of different ways that we can solve them. One of the problems that happens, for example, if I have 4x squared plus 3x equals 0, in the past, you would use operations to get x by itself, and then you would solve for x. The problem is we have x squared and we have x. So how do I get x alone? What do I move to one side when there's two different x's and one of them is a squared? So there's different ways that we have to go about solving it. It's not as simple as 4x equals 8, and I just have to divide both sides by 4. There's a lot more that goes into it. The math isn't much more complicated. We just have to use different strategies. So first thing that we need to do is we want our quadratic to be in standard form, which is this right here. So we want something x squared plus something x plus c equals 0. There's not always going to be everything. Sometimes I might have 4x squared plus 2 equals 0. That's okay. Even though there's no bx right there in the middle, it's still a quadratic equation. It's just that b is actually 0, so there's 0 x's. 3x squared plus 2x equals 0. That's also a quadratic equation. We want it equal to 0, okay? So the first way that we can solve these when we set them equal to 0 is by graphing them. So the first way to solve, we put the equation, first of all, in standard form. Remember, that means it's set equal to 0. And then we graph it like we would a quadratic function. So my example down here, x squared plus 4 equals 8. X squared plus 4 equals 8. It's not quite in standard form yet because it equals 8. It doesn't equal 0. So I've got to get rid of this 8. I want to turn this into 0. So I'm going to minus 8 from this side, and I'm going to minus 8 from this side. So I get x squared. 4 minus 8 is negative 4 equals 8 minus 8. Now I have 0. So this just becomes x squared minus 4 equals 0. Now I'm in standard form. Even though there's no bx in the middle, this is the standard form because it's set equal to 0. Now what I want to do is graph it. So I go to my TI-84 or to Desmos, and I put in, oops, I forgot what my equation was, x squared minus 4. So I put in x squared minus 4, and I'm not going to set it equal to 0. I'm putting it in like it's a function. It's equal to y right now as a function. So when I hit graph, I get my graph right here. Now, because I don't want it equal to any y, I don't want x squared minus 4 equals y. I want a specific number for y. I want 0. So when I graph this, what I'm interested in is when y is equal to 0. So I look at my graph, and I look for my zeros. I look for these spots right here, my x-intercepts, because that is where y is equal to 0. So it's equal to 0 at these 2 points, and one of them is negative 1, negative 2. So when x is negative 2, y is equal to 0. My other point is 1, 2. It's positive 2. So x equals 2 when y equals 0. And those are the two solutions that I'm interested in. So if I go back to my problem right here, because y is 0 at the x-intercepts, those x values represent the solutions to the equations. So x equals -2 and x equals 2, those right there are my solutions. And I can check them to make sure, which is probably a good idea. If I plug them in right here, x squared minus 4 equals 0. Well, if x is -2, -2 squared is 4, minus 4 equals 0. Yes, that's true. So that one's correct. X is +2. 2 squared minus 4 is 4 minus 4, which equals 0. So 2 is also a correct solution. All right. So first way to do this, plug it in, set it equal to 0, plug it in as a graph or as a function, excuse me. Look at the graph and find those zeros when y equals 0 right down here. And those are your solutions. Okay. So x is equal to -2, x is equal to 2 are my solutions. Go ahead, pause the video. I want you to try number 3 on homework 7. Try number 3 on your own. Make sure that you can do that. If not, come back to the video, maybe watch this part again or use some help on the homework website. And then we'll move on when you're done. All right, solve by finding square roots. Another way that we can solve these equations, this one only works if the middle term bx is missing. Or in other words, it has to look like 3x squared plus 5 equals 0. There can't be anything times x in the middle. It can be 6x squared all by itself, but it cannot have this extra term b times x in the middle. If it does, we can't use this way of solving. We have to use something else. But if it doesn't, if that middle part is missing, then we can find the solutions for the equation. The first thing that we do is we solve for x. That's basically what we're doing, is we're solving for x. So for example, 2x squared minus 18 equals 0. This does not have that middle bx term. So we're going to solve for x. We're going to solve for this x. Step 1 is to get x squared by itself. So I have 2x squared minus 18 equals 0. I want to get x squared all by itself. So I need to get rid of this minus 18 and this multiply by 2. First thing I have to do is get rid of the minus 18 by adding 18. So this becomes 2x squared equals 18. I added 18 to both sides. So those went away. This side becomes 18. Now I've got 2 multiplied by x squared. To get rid of that 2, I divide by 2. And I'm left with x squared is equal to 18 divided by 2. It's equal to 9. Once I get to that point, once I get my x squared equals 9, I take the square root of both sides. I've got to get rid of x squared. I need to do the opposite of x squared, which is taking the square root of both sides. And when I do that, on the left-hand side, I get x. On the right-hand side, I get the square root of 9. And if you plug that into your calculator, it tells you 3, which is somewhat correct. 3 is the square root of 9. But something that you need to remember, square roots result in a positive and a negative answer. To illustrate, if I have 3 squared, I get 9. But if I have -3 squared, -3 times -3 is also 9. So the square root of 9 isn't just 3. It's a +3 and it's a -3. So I actually have 2 answers. X is equal to 3 and x is equal to -3. You can write it this way. It means the same thing. This means x is a positive and a -3. So remember, when you take the square root answer, you have a positive and a negative. Even if it's an ugly number, let's say that it wants the square root, or excuse me, let's say we have x squared equals 104. And I have to take the square root of both sides. When I square root 104, let's actually do that here. Let's get out of our graph. If I take the square root of 104, I get a big long decimal, 10.198. So I get that x equals 10 let's just round that to 10.2. But I also get a negative 10.2 because 10.2 times 10.2 is this, and negative 10.2 equals the square root of 104. All right, so let's do, just to reiterate, you have those two answers. Let's finish filling out the notes. The positive and the negative square roots are answers. Usually, we're going to, most often, you use both answers, okay? But every once in a while, the question that's being asked, one of those answers won't make sense. For example, if the question is asking you, if it's a story problem, and it gives you a equation and you get a positive and a negative answer, but the story problem involves distance or time, usually there's no such thing as a negative distance or a negative time. So you would ignore the negatives because those answers wouldn't make sense. Technically, they're correct, but in the story problem, they wouldn't make sense. And we're going to do one of those right down here. So two examples really quick. 6x squared plus 24 equals 56. First thing I've got to do is get this in standard form. There's no bx, so I can use the square root, but I've got to move this 56. So I minus 56 from both sides. We're going the other way around. We're getting x squared by itself. I've got a minus 24 from both sides. I'm sorry, we're not turning this into 0. We're getting x squared by itself. So minus 24 minus 24. So we get 6x squared equals 56 minus 24 is 32. And now I have to get x squared alone still. So divide by 6, divide by 6. X squared equals 32 divided by 6 isn't going to be a very nice number. Okay? If I do 32 divided by 6, I'm going to get 5 1/3. 5.33333. So x squared equals 5.3 repeated. So when I take the square root of both sides so that I get x all by itself, I get x equals a positive and a negative. I've got to take the square root of that ugly number. So I'm going to second square root, and I'm going to actually put in second answer. I'm going to put my 5.33 right underneath there. I hit enter, and my answer is 2.3094. So x equals 2.3, let's round it to the hundredths, 2.31, but it's the positive and the negative. So my answers are actually 2.31 and negative 2.31, and we write it like this. Okay, one more example. A square has an area 122 square inches. So the area equals 122. What is the length of the square? Well, if I have a square, I know that my length is the same on all sides because it's a square. And area equals this length times this length. So my area equals length times length, or my area equals length squared. Well, I don't know the length. That's what I'm looking for. So that's my unknown. The area I do know. It's 122. Now to find my length, I just take the square root of both sides, and my length is going to equal plus or minus the square root of 122. So square root 122, and I get 11.045. So 11.05. We'll round it to the hundredths. But this is a length. I can't have a positive length and a negative length. First of all, they have to be the same. Second of all, negative distance, negative length doesn't make any sense at all. So I'm going to ignore the negative, and my answer is just going to be the positive 11.05. Because in the context of the question, the negative doesn't make sense. You're going to have to be the judge. Does the negative make sense? If it's a story problem, you're going to have to make that decision if it does or doesn't. So go ahead, try number 1 on homework 7, pause the video, give it a shot, see how you do. Come back when you're done. Okay, third way of solving these equations. What do we do if b does not equal 0? Or in other words, what do I do if I have x squared plus 4x plus 6? What do I do if there's this x in the middle? Because I can't get x alone. I can subtract 6 from both sides, but now I have x squared plus 4x equals negative 6. And I don't know how to get rid of an x and an x squared. I mean, I can move the x's over here, but then I have x's on both sides. And it just becomes a really big, messy mathematical headache. So instead, what we do is we use the zero product property because it simplifies this a lot. What the zero product says is that if a times b equals 0, then either a is equal to 0 or b is equal to 0. So that makes sense. If a times b equals 0, let's put a number in here. Let's say that 4 times x equals 0. That only works if x is equal to 0. So if I have two variables, a and b, one of those has to be 0 so that my answer comes out to be 0. And we combine that idea, two numbers multiplied to 0, one of them has to be 0. We combine that with factoring our quadratics in order to come up with a solution. So, for example, I have a quadratic in standard form. If it's not in standard form, put it in standard form. Q squared plus 2q minus 63 equals 0. I want to solve this. Step 1, I have this q in the middle, so I can't just do the square root shortcut way. And I could graph it. That's one way to do it. The other way is to factor the quadratic. So I want to factor this part right here, q squared plus 2q minus 63. So I look for factors of negative 63 that multiply to 2. And let's get negative 9 and 7. Actually, negative 9 is not going to work because they need to add up to a positive 7. So my negative needs to be the 7. 9 times 7 is 63. Positive 9 minus 7 is 2. So when I factor this quadratic, I don't have anything in front of q squared. So this becomes q minus 7 times q plus 9. But remember this equals 0 part. So I factored those, but those are equal to 0. And here's what's cool. This parenthesis is being multiplied by this parenthesis. And when I multiply them, they equal 0. That means one of those has to equal 0. Or it means if one of them equals 0, if this one's 0, then my answer is 0. If this one is 0, my answer is 0. So now all that we have to do is set each parenthesis equal to 0. And then we solve it, and those are my solutions. So for example, q minus 7 is my first parenthesis. Set that equal to 0 and solve for q. Add 7 to both sides. Q is equal to 7. So one of my solutions is q equals 7. My other one, q plus 9 equals 0. Minus 9 minus 9, q equals negative 9. There's my other solution. So if I plug in a 7, I get 0. If I plug in a negative 9, I get 0. Now we can test this. We can plug them in to my example right here. Let's start with the 7. Let's plug in 7. So instead of q, I'm going to plug in a 7. And if it's correct, I end up with 0. So 7 squared plus 2 times 7 minus 63 is supposed to equal 0. 7 squared is 49 plus 14 minus 63 equals 0. 49 plus 14 is 63 minus 63 equals 0. And that definitely equals 0. So that is a correct solution. I can do the same thing with negative 9. I can plug in a negative 9. Negative 9 squared plus 2 times negative 9 minus 63. Negative 9 squared is 81. 2 times negative 9 is minus 18 minus 63. 81 minus 18 minus 63 equals 0. So that is also correct. Those are my two solutions. So 2 other examples. This one's already factored for us. So we can go ahead and just plug each of these equations in and set it equal to 0. 3x minus 2 multiplied by 5x plus 5. So 3x minus 2 equals 0. I solve for x. I add 2 to both sides. 3x is equal to 2. I divide by 3, divide by 3. X equals 2/3. I like that answer way more than decimals. So don't actually divide that. Just leave it in that fraction form. And then 5x plus 5 could possibly be 0. So I minus 5, 5x equals negative 5. Divide both sides by 5. X equals negative 1. There's my other solution. I can plug them in and check my answer. Make sure that I still... So for this second example, 7m squared minus 19m equals 6. Takes a little bit more work because, well, first of all, it's not in standard form. It's not equal to 0. So first thing we need to do is minus 6 from both sides to set it equal to 0. So I get 7m squared minus 19m minus 6 equals 0. Now this one on the left was easy because it was already factored. This one I have to factor. So I'm looking for, because of this m squared, here's where the last unit test, you really need to understand what you were doing because we still have to factor. This 7 in front of the m squared means that I have to multiply these two together. So that's negative 42. And I'm looking for factors of negative 42 that add up to negative 19. So factors of 42 are 21 and 2, 7 and 6. We can also do 14 and 3. But they add up to a negative, and they multiply to a negative. So one of those has to be a negative. And since they add up, it's the bigger one. Negative 21 plus 2 equals negative 19. So that's what I'm going to use to factor. So 7m squared minus 21m plus 2m minus 6 equals 0. I'm just going through the factor steps that we did in the last unit. I'm not going to slow down for this part. You're going to have to remember this or go back and relearn it from the past videos. I factor out the greatest common factor, which is 7m. So I get m minus 3 on this side. I factor out the greatest common factor over here, which is 2, and I get m minus 3. So one of my parentheses is m minus 3. My other parenthesis is 7m plus 2. And those are equal to 0. Now I can just set each of them equal to 0 to find my solutions. M minus 3 equals 0. I add 3 to both sides. M equals 3. There's one solution. 7m plus 2 equals 0. Minus 2 minus 2. 7m equals negative 2. Divide by 7. Divide by 7. So m is equal to negative 2/7, which is a great answer. I don't want the decimal. That fraction right there is a good answer. So if I plug in m equals negative 2/7 up here to this equation right here, I should get 6. If I plug in m equals 3, I should also get 6. You can go ahead, plug those in, give it a try. Make sure we did the problem correctly. Every once in a while, just the last note before you go on to the homework. Sometimes a problem asks for a solution in roster form, or it asks for a solution set. So far, we've been writing x equals 2 and x equals negative 2. The only difference in roster form and solution set, they're the same thing. If I had the quadratic x squared plus 5x plus 6 equals 0, I would solve it and I would find that x equals -2 and x equals -3. Instead of writing it like this, roster form or a solution set means that I write it with brackets. So I put a bracket and then I just write one of my answers and a comma, and then I put my other answer. You need to be careful that you use these special brackets. Don't just use the parentheses. If I put -2 comma -3, that means a point on a graph. If I put the bracket -2 comma -3, that means all of the numbers between -2 and -3. I have to use the fancy little brackets like this. That means that that -2 is a solution and -3 is a solution. Okay? So I think the last two problems ask for a solution set, which just means write it with the fancy brackets. So good luck. If you need help, come in and see me. I'll be happy to do what I can. Homework 7, remember it's due on Friday.